Hi everyone, this is Tim Halverson with Sevenfold, and in this episode we're going to be looking at how you can make a stair generator. And on screen you can see that we've got this staircase that was made only using a curve, this curve here, which is completely customizable in Rhino. You can move it, you can flex it, you can just use a few control points to change that. And then the other thing that's exciting is what it's all based on is this one tread right here. And so basically you can model a single tread, you can model a curve, and then you can set the height of what this is going to be, the floor to floor height. And you can also set the tread depth, the riser height, and then from there we're going to do a separate one that deals with some of these gaps that come in here where you need. But essentially this is going to give you a really quick and dirty way to have design intent and get something looking like this. The other big thing that we're going to be looking at is how to use the relative item component. You may not know exactly what that is, but if you are familiar with Grasshopper at all, we're going to be covering how to use the relative item and then have this by the end of it. So without further ado, let's go ahead and dive in. So why don't you go ahead and start up a brand new Rhino. Now the first thing I want to do is two things. I want to start with drawing my curve, and basically you could just kind of start to draw any curve you want. This is going to be what drives the path of your stair. And I'm just drawing that in plan, and I'm basically thinking this is going to be the floor that I'm starting on, and then I'm sweeping up to be a floor that's at some height. What I want to do next is go into Grasshopper, but first let's go ahead and build up our tread. So I'm going to use the rectangle corner to corner. Actually, let's just do the box. And I'm going to use a 3-point box and turn on grid snap for a second. So it snaps to the grid here. I'm going to click once. I'm going to type in 12. And let's just see, 12 inches. There we go. And I'm going to do 48 inches wide. And let's just do 1 inch deep. And I'm going to flip on to Arctic color just so I can see a little better. Okay, cool. So now this is a pretty basic stair tread. Now the best part is that both of these are modeled in Rhino. So I can change either of them, and that's going to allow me to change it later. So the goal is to basically map this tread along the curve at different heights and have it oriented to the curve as well. So go ahead and type Grasshopper and hit the space bar to launch that. You'll probably see me double click from time to time to open this up. So the first thing I want to do is grab the brep container component, click that, right click and say set one brep, click my new tread. The next thing I want to do is grab my curve container, and I'm going to reference by right clicking set one curve, click that curve, and if we hide those, you can see that it's showing up in Grasshopper. The first step we want to do is break down our tread so that we can get the shortest edge. And from the shortest edge, we're going to use that as the distance to divide up our curve. Okay, so first thing I want is to go to Surface, go to the Deconstruct brep, and plug in my surface here. The next thing, I've got my faces, edges, and vertices. I want to get the centroid, so I'll just type in area by double clicking. If I plug my faces into that geometry, it's going to give me the midpoint of each of these surfaces. And then I just want to get the topmost surface. So I want to sort all these points and get the one that's towards the top. So if I go to the vector and go to plane and then go to plane coordinates, this asks for a coordinate system and points. And so by default, if I hover, it says world XY. I like to be able to read that later, so I'm just going to type in XY to get the world XY plane. That's going to give me a representation here of the world XY. And I'm going to plug that into the coordinate system and then plug all my center points into the points there. The next thing I'm going to do is type in SOR, sort, to sort list. And I'm going to use the Z value to be the key. So that K is for key. And what I want to sort is actually my faces. Okay. So this basically measures how Z, so up and down, from relative to the coordinate system that's been put in, which is the world XY. And it's going to sort against that. I think this is a pretty important topic. Let me just diagram that quick for 2 seconds. So basically, this guy here, you get a plane. In that plane, you've got Z, you've got X, and you've got Y. I don't know if that's visible. Z up, this way is Y, to the right is X. And what we're doing is we're basically plugging in these points that come in right there. And each of these points is coming in through my center point to here. And that's each of these points here, okay? Actually, it's not the edges there. So if I just hide that. Okay. And then we're grabbing all these points here on the center, and then it's measuring each of those points by the Z. So the Z there. So as it's going to see, okay, relative to this coordinate system, this one is going to be the highest because I know it's at the topmost face, and each of these points are going to be lower than it. So if I look at that in elevation, the midpoints of the other faces are below that, and then the highest face is going to be here on the top face. So that's what I'm sorting to. I'm going to grab that point and be sure that I always get the top face. Okay, and that's basically what the sort list component is. It's going to say sort using the keys by the Z, and then what am I sorting is an A, and that's going to be my faces here. So that's what's going on. Okay, so to get the topmost face, I'm going to do list item, which should be by default the 0 most index, which is default item here. So plug that in. And if I look at the keys by doing quotes, enter keys, you can see there's the keys. One is 0 distance away from that coordinate system. That's the highest point. That's actually the one I want, which happens to sort to the very end. So all I have to do is reverse this list by right-clicking, reverse the list. Now if I select, it's got that topmost face. Perfect. So I'm just going to select all this and hide that and delete that. Okay, so now I've got just the top face to work with at the moment, and I want to break this down as well. So we're going to reuse that component, go to surface, deconstruct brep, plug in that surface. It's going to give me a faces, edges, and vertices. We're going to go ahead. We're going to get the one closest to the curve. So I want the one that's closest to this curve. So I'm going to do evaluate curve. So type in EVA, evaluate curve. Right click on the C, reparameterize that. And then plug in the edges to curves. And then we're just going to do a panel by doing quotes, 0.5 to do 50%. And plug that in the T. By reparameterizing it, it makes, no matter what the length of the curve is, it makes it a percentage from 0 to 1. So 0.5 for that. Now, and I'm doing that here on these edges here. Now I'm going to do CP to get a curve closest point right there. And then I'm going to plug in the points. Whoops, undo, Control Z. Points to the P. And then the curve I want to put in is actually my curve over here. Okay, and I'm also going to reparameterize that at the moment. So you can see it's put these points on here, and it's basically pulled all these over. I'm assuming that I've modeled it on the shortest side. For argument's sake, let's just go with that. Okay, so now we want to sort by the distance. So I'm going to sort tree again, plug this D for distance. That's how far it had to travel between here and there. So that's going to be my sorting key, and I'm going to put in my edges to what I want to sort. I'm going to do that same move by typing an item, and this time I want the closest one. So if I grab that, you can see what's highlighted in green is the edge there. Okay, so you can kind of see it right there. Okay, so now why did I get that? Well, I want to know how long that is. So by typing in length to get the curve length, I now know how far I want to set my my treads. Okay, so what we're going to do now is start to work with the curve, this curve here. So the first thing I want to do is do divide distance. So by typing in div, divide distance, plugging in that curve, and then the distance, we could plug in any number. However, I wanted to derive that number based off of the length of my input brep. So that's why we broke down the brep. So plugging that in, now you can see this division is going to be based off of that tread. So now if I just type show, bring back my tread, if I wanted to change that, that's going to increase the distance that it's dividing up my curve. Cool. So now I want to start mapping my tread to these different points. But the first thing I want to do is actually figure out how high I want to go. So I'm going to put in a slider that goes 1.00 less than, what do we want to do? Let's do 12 feet, which is our floor to floor height, and I'll put it up to 20 just in case I want to change my mind. I'm going to right click, call this floor to floor height, and in parentheses I like to put feet just so I know what units I'm dealing with. And then we're going to go ahead and we're going to start lofting these points up to that height. So if I just did a simple move command by typing move, and then if I double click and type Z to go in the Z direction and just simply moved all these points up, it's going to put them up here. Okay. But I want to do just the number of treads that I need to go up 15 feet, or actually 12 feet in this case. I only want as many treads as required to get up to 12 feet along this curve. So I don't need all these. And the other thing is I need each of them to step at a certain increment, which is going to be my riser height. Okay, so how do we get there? Let's go ahead and create a new slider. We're going to go, let's do something logical. Actually, I'm going to change my units just for ease. So I'm going to go to options. I'm going to go to my units. I'm going to change it from feet to inches. Hit OK. And I'm going to accept yes to scale things. Cool. And so now this actually is, instead of feet, this unit is going to be in inches. But I'm gonna go ahead and just multiply that by 12. So let's just do a little star symbol for multiplication. And I'm going to type parentheses 12, enter, multiply that by 12, and now that's converted to feet. Okay. So next thing I want to do is I'm going to do another slider. I'm going to go 1 And if you're real smart, you can look up the International Building Code by saying 4, because you can have a riser no less than 4 inches. Less than 7, actually let's do less than 6, less than 7.0. That gives me an extra decimal. And I'm going to call this riser height in inches. Those are healthy constraints because that's building code. You can't go more than 7. So don't build higher treads than you're allowed. And then I'm going to repeat that for the tread. So I'm going to go, let's just do 1, less than 12, less than 36. Why not? And I'm not sure if I'm going to use that actually, but tread depth in inches. Okay. So to get the riser height, we want to divide our floor-to-floor height by our riser height. And the result is going to be 20.5. So I need at least 20 risers at 7 inches. Now if I go down to 6, it's going to go up to 24. It's a nice even number. But let's just do 7, because then I'll show you how to do it with the fraction. Okay? Just for argument's sake. So 20. And we're going to go ahead and do round factor. If you don't know this component, if I hold Control-Alt-Click, this is pufferfish, and it's a really useful component set. Highly recommend it. Go get pufferfish if you don't already. And this is the round factor component. So I'm going to plug in. So I'm going to plug in this. I'm going to say panel with quotes 1, round to the nearest 1. Plug in that, and it gives me 21. But then if I go to the type, I'm going to right click and set that. You see, if you hover, it says 0 is nearest, 1 is floor, 2 is ceiling. I want the floor. So I'm going to do set that to 1. It gives me 20 instead of 21. And then it also gives me the difference, which is that fraction that came out. Now if I just simply do a multiplication and do that by 12 as well, I can just click, drag, and hold Alt to create a copy. Plugging that in, plugging in the difference, it's going to give me 6.8 inches. And if I want to be fancy, I can deal with that. We're just going to leave it as a weird fraction. I could round that again, and this time I could round it to the nearest eighth, like 0.125. But we'll get into constructability and rounding later. I just want to get this as quickly done as possible. So 6.75. All right, so let's just keep it a weird fraction. Cool. Moving on. This always takes longer to explain than you want to. All right, so next we want to do a series. And the series has a start of 0, a step of 1, and a count of 10. I want my actual step to be my riser height. So that's going to be this guy. I want to start at the first height, so not 0, but I want it to start at 7, so my first riser height. And then the count is going to be this number of risers right here. So we're going to do that. The result is going to be, if I pull up a panel, plug that in, a whole bunch of different inches. So there's 20 items starting at the 0th index, so 20 items. And each one is going to move at a different increment. So if I just simply take thought and plug it into the Z, boom. Now we need to tweak this a little bit because we've got only so many points and we want to get rid of the ones we don't need. Plus we also want to get our fraction in there too. So we want to insert item. So type in insert items. The item that we want to insert is the difference, which is this D. We want to insert that at the end So if I do item index, or let's do last index right there. And I want the last index of my series, which is going to be 19. I want to right click and make that +1. So let's do x plus 1 to make that 20. And I'm going to insert that at the end. And we're going to insert that into this list of our series. So it's going at the end here. Now, one more thing, we have to add this fraction to the end, to the last number in the series. So how do we get there? Well, we can repeat that list item. We can get rid of the expression. And then we can do an item index, list item. Grab the series, plug that into the list. Do the last item, last index, plug that into the index. That's going to give us our 140, which is the last item. And then I can just do a plus for addition and add my difference. And now we're going to have 140.57. And that's going to be added in, and that's going to be the item we add. Boom. So there we go. So now when we take these guys, put them in, it's going to give us that last little fraction of a step. Okay, cool. So now what we want to do is we only want the number of points to move as the number of steps we need. So how do we get there? Well, we want to do shortest list. So typing in shortest list, it's going to compare the two incoming lists and take the shortest of the two. So I'm going to take all these vectors we made, put that into B, put all my points, put that into A, and you can see we keep our 20 vectors, but we also chop down our point list to be 21 items as well. So putting in A to points, putting in B to vectors, now we only have the number of risers we need. Okay. Next, we're going to build a plane, and basically what we're going to do is eventually we're going to get to this command, the orient command, and that's going to help us map this tread onto all of our riser points. Before we go any further, I just want to make sure that we get this all grafted appropriately. So what I want to do now is type in graphed, get all of our newly moved points into their own branch right there. And now you can see this is the branch. It's a little complicated, so I'm going to right click on that and simplify. And now we've just got a nice clean set of branches. Okay. Now, how do we get our geometry up onto these points? We want to build a plane. So let's just browse there. Go to the vectors, go to construct plane. Excuse me. Plug our points into the origin. And this is going to give us a default. The X and Y are to the global direction, but we would want them to be tangent to the curve that we are inputting. All right. So how do we get that? Well, the way I've solved this is using the relative item component. So if I use relative item by typing in rel, what this does is if I put in the points, it's asked to the tree here, right? So this has to have branches. And let me try to explain this. Let's use the sketcher. Okay. So, okay. So this is an incoming set of branches. And each of these is our branch. Now, right now they're all at the 0 index because there's only one item in each branch. Now when I use the offset here, there's a syntax, which is the curly braces, which is that guy. And you can do plus or minus. I'm just going to do plus 1 and then curly braces to close that. Now, if this was a more complicated branch structure, like if it was, you know, something like this, 0, semicolon, 0, and then brackets, what you'd have to do is you'd actually have to go to the, the item in the branch that you want to target. So in that case, I would go 0, comma 0, colon, plus 1, and that would be what I type in. Okay, so if I do that, do a quotes for a panel, semicolon, plus 1, semicolon, enter. It's going to be a panel with the semicolon plus 1, and we'll plug that into the offset. These are wrapping. W sub P is we're not wrapping by default, and so that means once I get to the end of this list, it's not going to grab additional items after that. Okay, and then let me hide this. So in the A is the original branch, and B is the offset branch. So if I merge these and do a P line, polyline, not too exciting at the moment, but what I want to do is actually do renew our construct plane, and I'm going to do it. We've already got that here. So what I'm going to do is project, and I'm going to project the relative point above it down to the plane below it. I don't know if that made sense, but we're trying to make this work. So what is that doing? If I take my newly projected point and plug that into the B, that's actually grouping it. You can see here, it's grouping it on its own branch. So when I've got each of these branches plugging into my polyline, that's giving me those 2 points. So it's taking this point from up here, projecting it down onto that plane. So this point, I went and grabbed this plane here and projected it down to there, and then built a polyline between the two. Okay, and because they're each on their own branch, I was able to do that across the entire system in one go. Okay, this gives us a lot of flexibility, and this is probably the most powerful thing of this whole tutorial. Okay, so what do we do now with all of that power? We want to create a vector between these 2 points. So this is visualizing it. I want to do 2 point, so typing in 2 point vector. And instead of creating a polyline, I just want to do A into A and the projected point into B. If I want to visualize that, I can type VD for vector display, anchor that on A, put the vector in, and you can see that's the vector we want right there. Okay, so now if we do different way, this is better. So I'm going to deconstruct plane, which is the planes that we made, and that's these first ones. This is going to have my X, Y, and Z vectors from the planes we already have made. I want the vector here for Y. So we're going to go angle, type angle. This is going to ask for 2 vectors, so I want my first vector to be my Y, and then my second vector to be this newly formed vector. And if I check that, the angle is that, it's in radians by default, so if I just right click and do degrees, type degrees, convert my radians into degrees, it has a series of different rotations we're going to do. And now if I just do rotate, we're going to take the planes and we're going to rotate them. I'm going to right click and convert that to degrees. So right click degrees, and the angle is our newly converted degrees there. And the plane we're doing that on is the original plane, not the world XY. Boom. So now you can kind of see, and it went the wrong way. So we just need to flip that. Let's just do -x. Boom. So it went from this Y to that Y right there. And now everything is kosher. Okay. This is not the right use of kosher. I'm sorry. So now I'm just going to hide some of this to reduce the confusion. Okay. So now we have our oriented planes. We can check it if we want. They're all in the right direction, which is beautiful. And now we want to get our tread up onto those planes. So the geometry that we're putting in is going to be our tread here to the G. By default, it's the world XY. I could also put that in to be explicit, to be the world XY. It's assuming you model it right on the XY. You could also grab one of these points, or even better, you could click, you could make a new plane container and just do right click and say set one plane. And then this will give you a tooltip in Rhino. And I can click once to set the X, another to set the Y, and now that is set. That's going to be the plane A that's pulling from, and then plane B is going to be these ones we just made. Boom. Okay, so now we got a staircase. And you can see right there, it's also adding that additional partial step. Now, if you wanted to, watch this. If I wanted to be fancy because my orientation plane is there, I could grab this edge by Control-Shift clicking, and I could pull that out a little bit. I could start to work with it, and we could work with it. I could also add additional information like a line in Rhino, and I could say go from the world XY to this point here so that this is the nosing, and we could input that as a curve, and then putting that in as the curve length to set the tread depth. That's going to keep these tighter, and it's going to allow us to have a bit of a nosing. All right, so you could also scale 1D and just kind of work with that. It's going to reduce your tread depth and increase that nosing overlap. Likewise, you could test to see if this is working for you. You could reduce the riser height to like 6, and that should all just update. We could also test the curve that we're working with and bring that down. So this is the fun part, right, where you get to kind of explore what you want to do with your design. And I will leave it to your discretion on how beautiful or unbeautiful you want to make that. All right, so it's up to you. Now, the final thing I was going to do, I realized we're getting long on time, but let's show how to actually connect the railings in there that was another key piece of the geometry we made. So if you remember, we have this custom tread that was basically made by working with that original base geometry down here, and like we showed here, you could Control Shift click, go to C planes and set that to object, or just do C plane by 3 points, and then I basically just model the curve on here and disable grid snap. Little plane wing, and I'm just gonna pull that out and then type extrude curve and extrude that curve all the way through. I'm gonna select my tread, type split, select the cutting object, which is my new extrusion, hit enter, and then I'm gonna Control click to keep the part I want, or whoops. Just delete that, and then I'm gonna take the extrusion, type split, and then select cutting objects, which is my poly surface I just made, and I want to Control click to keep the part I want, and I have a shortcut for Control Q to delete, and now we've got our new tread. I'm going to select both those holding Shift, and then join those. So now I've got a new poly surface. You can see it didn't update automatically because that made a new B-rep, so I just have to right click on my container, set that again, and we are good to go. And so now you can see that geometry has updated to be that kind of reverse plane wing tread, which might be a little dangerous, so I would highly recommend making that a little smoother, but that's what you do. And alright, so final thing we're going to do is build the railing. So now that we've got this point data, how do we get the actual railings in there? So let's go back to the end of our canvas here, and let's just add a quick note and call that treads. Alright, so if we just type in line, take our original point and tie that to the projected point, it's going to give us our point here. And then what we're going to do is we're going to evaluate that. So evaluate curve. I'm going to right click and reparameterize. And then we're also going to just give ourselves a slider. So 0.00 less than 1. Plug that in the T. And then you can see that's going to give me a sliding point along that rail we just made. That's going to be where we put our railing. And now I'm going to move, let's go move in the Z direction. So type Z. And by how much? Let's give ourselves another slider. 1, let's actually go negative. -6 less than 36 less than 42. So that's going to give me a slider starting at 36. And plugging in my point to that, you can see that's going to move these points vertically. If I just do a line now to my newly formed points, you can see that's starting to get the railings I want. So now if we also move the bottom point by selecting these, click Alt to copy, and then we're going to bring that down to, let's do the negative, and then I'm going to use that as my base point. Now you can see that railing is sweeping along there. And finally, we wanted to create one more line that to get that kind of stepping effect. You can see here we've got that kind of bevel going on. We're just going to create one more of these, and we're going to reduce that line down here and set the top point to create another line. And now we're going to also reuse that relative item. So if I just come back here, select this, click, drag, hit Alt, make a copy. And then I'm going to grab the newly shortened one and plug that into the tree. Now let's just double check to make sure our branches is correct. So if we double click, do quotes for a panel. Okay, so we still have a pretty basic structure, so this will work. Cool. So now if I do a merge and I take the B, put that into the merge here, and then we'll plug this one into there. That's going to basically create one of these and then the one in front of it, and put those on the same branch. So now if I loft, typing in loft, it's going to create a seamless sweep down here, and then it's got that flexible height up here, so you can see that shifting. And this, since they're using the same point, is going to be always tied together. Cool. So now the final step on that one, we'll add more detail as we go, but you can see there's kind of an inset to create that panel. So if you wanted to turn those into frames, what I like to do is go up to surface and beer up edges, kind of unpack that newly formed surface, and then I'm going to join those curves, typing J, and we want the naked edges. It should just be 4. Yep, so it's just 4 per branch. And that's formed a single polyline curve. If it's orange, don't worry, it's probably something at the bottom where it's empty. That's fine. If you're concerned, feel free to just run a clean tree and remove empties. There you go. And we should run that over here. So running that on the loft before we get this in. Okay. And then we want to do a quick offset. So offset, Kev, plug that in right there. And this is always kind of quirky. So there's some places where it's going the wrong direction. The way to solve that is to set a plane in this P here. So we will evaluate the surface to get the plane of our newly formed lofts and put that into the S, and then we'll just double click and get an MD slider. This is going to evaluate that surface at 50%, 50, and just right click to reparameterize and make sure it's in the middle. Now if we take the F, I mean there's a million ways to say plane, but for the frames, which is a plane, we put that into the plane. You can see now they're all consistently going in the wrong direction, but at least they're consistent. So all we have to do to flip that is just right click on the D, type expression -x, that'll flip it, and then we can actually type in a distance. So I'll do 0 less than 0.5 less than 2. And so now if I use that slider, that's going to increase how far we inset. And now if I just do, I can actually just browse to it. Just do a boundary surface, put in those edges. It's going to give me a new surface on that newly formed panel. Okay, cool. We're almost there. How do we get the railing now? Well, we just want to grab those points that we moved up earlier. So that would be these guys, these points here. And they're all currently on their own branch, but we want to get them to all sweep together. So to do that, we just flatten the tree. And then we want to do, let's just do the curve here and this interpolate curve. Plug all those points into the V for vertices. Okay, so what I found out was if I used polyline curve instead of interpolated curve, that would help fix it, because runtime warning says 0 length segments were collapsed to create a valid polyline. So that means there was a couple points in there where it was redundant. That gives me a valid polyline curve. I'm going to do that also for the moved points. Now we've got our polyline up there. And now to get some geometry, we want to, let's just pipe it. So pipe, input a curve, and the radius, we can do flat or rounded caps, do flat. And I'll set the radius to be 0, let's do 0.5. So it's going to give me a 1-inch diameter. And there you go. So if I want to repeat that, I could just copy that by dragging Alt, plug in the other poly curve, and you could play with it, dragging different radiuses, changing their size. I'll let you work with that. Now finally, if you want to get this all out, easy enough to just right click and bake. I'm also a big fan of using Elefront, so if you just if you don't have this Elefront component, I recommend it. Just over here on bake, and then I'm going to build up the geometry and the attributes. Basically all you need is Elefront attributes. You're going to need a layer to put it on, and if I just grab one of these ones like layer 03, I can just type that in to the name. If I don't specify a color, it uses the default. Plugging that into, define object attributes, not this one. I'm going to put in layer right here. I'm going to plug in those those attributes here, and then I'm just going to merge all of this into a single bake operation. So we've got those panels, and then we want our treads as well. Cool. And then if I just type in a button, BU, and change that to, plug that in, change the wire display to hidden. Then you can move that to the front if you want. This is where I like to put my stuff. And if you bake that, it all bakes in one go. And there you have it. A parametric staircase in Grasshopper. Obviously, you can start to change the riser height, the tread depth. In the next one, we're actually going to get into what happens when you go around the corner here, and you actually need to get something that can deal with those wider depths of the tread on this side, but still keep the minimum on this side. So we'll get into that fabrication stuff later, but hopefully you learned something in this one. And Yeah.